Ranking result sets is a very common task. Some examples include figuring out which products are your best sellers, determining top producing salespeople, or organizing data into subgroups. And in the past, writing T-SQL to perform those operations was very involved, usually required temporary tables and cursors to get that output. SQL Server 2012, it's very straightforward. There are specific functions designed for ranking data. Row number, rank, dense rank, and entile. Let's take a look at the row number function. It's the simplest way to assign a number to each row in your result set. You first specify how to order the data, as well as how to optionally divide it into subsets. And if partitioned, broken up into subsets, then the function applies the ranking rows within each subset. Here's the syntax. Row number, and then we use the keyword over, and we have a partitioning clause. How do we want to break it up into subsets? And then we also optionally give it an order by clause. How do we want those rows within the subsets ordered? Here's an example where we're going to use the row number function to figure out our best sellers. And what we're going to do is we're going to partition that data by subcategory name. And you can see there we have an over partition by PSC .name, and PSC is referencing our product subcategory. So we're going to group these or put these into buckets based on their subcategory. And then we're going to sort and produce the rank number based on the highest to lowest sales volume. So you can see that we're ordering by a count of our product ID, how many orders have been placed for that particular product, and we'll do that in descending fashion. And what we're going to end up with is buckets of product categories showing our best sellers for each product, showing our best sellers for each subcategory. So here's an example. We can see that we have mountain bikes listed here, and we have our rankings, 1 through 10 shown there based on our sales volume. And you see it's from highest to lowest. It's very simple, but it's also very arbitrary. There's no way to handle any ties. What if we had 2 products that have the same sales volume? We need to figure out how to handle that. And that's where the rank function comes into play. It has the ability to handle ties, takes the same arguments as the row number function, so it'll be very familiar. And it'll assign the same ordinal value to rows within a partition whose order by expression results in a tie. So anywhere we have a tie, the rank function will assign the same number. And here, just for your reference, is the syntax. Again, same exact syntax as the row number function. And here's an example of what the output looks like when we execute a query that results in some ties. You can see here that rows 18, 19, and 20 for the mountain bikes all had the same sales volume, so they are assigned the same ranking. What's interesting, though, is it can't guarantee that these numbers are going to be consecutive. And if you take a look at the output here again, you'll notice this. Rows 18, 19, and 20 have all been assigned the ranking 18, which is correct because each of those particular products sold 228 units. However, the very next row, row 21, was assigned the ranking 21. And we might expect that ranking to be 19, as it's the 19th best-selling product. So SQL Server supports a dense rank function. It also has the ability to handle ties, takes the same arguments as row number and rank, but it will return those rankings without gaps, so we'll always have consecutive numbering. Again, for your reference, just the syntax, identical to the last two functions. And now you can see we do have the consecutive order that we were expecting. Again, rows 18, 19, and 20 all assign the ranking 18, and then row 21 picks up with 19, so that's what we expect. No gaps in any of the rankings. Finally, there's the entile function. It's very similar to the other ranking functions, but allows you to subdivide those partitions. And it returns a ranking number indicating which bucket within a given partition that row belongs. Here the syntax is entile, and in the parentheses we put an integer expression. How many little subdivisions or buckets do you want to divide your partitions into? And that integer expression must be a positive integer, and that'll indicate the subgroups. Now what's interesting is if the number of rows within a partition can't be evenly divided by the integer expression, SQL can't place the same number of rows into each subgroup. So for example, if there is a partition containing 15 rows, let's think of our prior example, we have subcategories of bicycles, and one of those subcategories contains 15 rows, and we wanted to take that subcategory of 15 rows and break it up into 4 smaller groups. Well, we can't do that evenly, but SQL will take care of this for you as best it can, so each of the buckets will be broken up as evenly as possible. And so here in the example you'll see that buckets 1, 2, and 3 each have 4 rows, and the remaining 3 rows in bucket 4. So let's take a look at this example. What if we need to generate a list of all bicycles grouped by their category? That would be the partition by clause. We want to sort that list from the most popular to least popular. That's the order by. And then we want to subdivide each one of those groups into 20 segments. That's going to be the integer expression used in entile. So here's the beginning of that query. We're selecting the columns that interest us. We are going to perform an entile 20. Again, we're going to take those partitions, in this case are categories, and we are going to break those up into smaller groupings. In this case, 20 little buckets for each category, and then we will order those in descending order from most popular to least popular. And here's an example of that output. So let's go into SQL Server Management Studio and take a look at each of these queries in greater detail. Okay, back in SQL Server Management Studio, and we're going to take a look at each of the ranking functions in this set of demos. We're going to look in greater detail at each of the queries that we developed before, and we're going to start off with our row number function right here. This is the one that's very arbitrary, just assigns a row number to every row it encounters. You can see here that we are going to define our partitions based on the subcategory name. That's the PSC.name. PSC is mapping to product subcategory. And then we're going to order those rankings based on the number of sales for each one of those products in that particular category, and we'll do it in a descending order so that we see most popular to least popular. And you'll see that that's a continuing theme with these examples, but first one here will show you how this works. Very quick, very down and dirty. We get our rows, and one of the things that we want to be aware of is if we scroll down here, you can start to see that we have some ties here. In fact, here's a couple of more, and a couple more. And you can see that the ranking continues to go up. And that's because row number is very arbitrary. And that might not give you a very accurate sense of where these products fall. So we're going to dismiss row number and move on to talk about the rank function. Because the rank function has the ability to deal with ties. and it has the same syntax. So here you can see that we are partitioning by our subcategory, and we are ordering in a descending fashion based on the popularity of the product. And so if we execute this, let me just move this up here a little bit for you, and we come down and we start looking for those ties again, here are those rows where we have tied results, right? But you can see here that the rankings are at least consistent. You know, there's a group of 18, a group of 21, a group of 23. Now we have these very distinct rankings, and it's a little more accurate than the row number, but now we have another problem. The other problem here is that these indeed all have the same ranking, but now we have these gaps. We have 3 products at the ranking of 18, and then all of a sudden we jump to 21. And perhaps what we really want to see is 18, 19, 20, 21. Consecutive ranking, no gaps. Well, there is actually a function for that. So we're going to dismiss this particular example and talk about dense rank. And that's exactly what this does, is it removes those gaps. So the syntax, other than the word dense rank for the function name, is exactly the same. And we will execute that. Scroll up here and take a look at the results. And here we go. And now we have those same rows highlighted, but you can see that indeed we have 3 18s, which all make sense, and then we have the 19s and the 20s. So we're getting the functionality and the ranking the way that we wanted. Finally, let's take a look at that end tile. The only difference between end tile and the other functions, the partition clause is the same, the order by clause is the same. The only thing we're doing is saying, look, I've broken these up or partitioned these by subcategory. That's what this clause is doing. And what I want you to do is take that group of rows and further divide them into 20 little buckets, and try to make those buckets as equal as possible. And so when we do something like this, you can see the results look a little bit different. And what we see here is we have 2 rows that are falling into the first bucket, 2 rows in the second bucket, third bucket, so forth and so on, until eventually we get down to where they only need 1 row to fill the bucket to get to 20. And so it's just a way to subdivide that partition a little bit more. In fact, the easiest way to kind of see this and be reminded of the fact that we are renumbering or re-ranking those rows every time there's a break on the subcategory is you'll see here these rows all belong to the mountain bikes category. And as we scroll down, we have a shift from 20, those little sub-buckets. We have a shift from one category to another. We're going from a ranking of 20 back to 1, and that's because there's been a change in the category. So again, a neat way of taking kind of a large volume of rows, your partition, and breaking them into smaller buckets for analysis.